Warning: chemistry is extremely dangerous. It involves the use of highly corrosive chemicals, strong oxidizers, and noxious gases. Please do not attempt to recreate without the proper background, knowledge of all chemicals involved, and safety precautions.
What is that?
This is moisturizer.
Show me what that is. Chloroform?
Is that what that says?
This is bleach. It's an extremely common household chemical and is most often used as a disinfectant or to get stains off light-colored clothes, but it can also remove the coloring of the clothes if used on darker colors. The official name for bleach is sodium hypochlorite, which is a yellowish chlorine-smelling liquid and the active ingredient in the bleach, though it usually only accounts for 5 to 12% for the concentrated stuff. Another common household chemical is acetone, and if you're a girl or someone who likes toes, you'll immediately recognize this as nail polish remover. I decided that these two were not being utilized to their true potential and I should actually use them to make chloroform. Historically, chloroform was used as an anesthetic before it came out just how toxic it can actually be, but some doctors and patients also realized if you inhaled just a bit of it, you got the 1800s version of galaxy gas. In the modern world though, it's been used as a precursor in dyes and detergents, in the manufacturing of fluorinated carbons such as Teflon, and as a lab solvent, but it's most famously used to knock people out. Finding a website that'll sell me chloroform would probably be a bit cheaper than this and a lot easier, but there's no fun in that, so I decided on sketchy and questionable garage chemistry instead. Before I get started, I just wanted to reiterate that chloroform and concentrated bleach are both really dangerous. I'm using a fume hood, goggles, and a respirator for both organic vapors and acid gases during this experiment. To start, I poured about 950 milliliters of 7.5% sodium hypochlorite bleach into a 1 liter beaker. I turned on the stirring and let the bleach cool. This reaction is extremely exothermic and can become quite dangerous if allowed to reach higher temperatures. The bleach was allowed to cool to near 0 degrees Celsius or 32 degrees Fahrenheit before the acetone was added. To the cold bleach, I added about 23 milliliters of acetone, which is a slight excess of bleach. Using excess bleach is important because all of the acetone needs to be used. Any extra acetone can be extremely hard to separate from the final chloroform product. And yes, I did check to make sure the windows actually opened for the fume hood this time, and I wasn't just blowing it back at myself for an hour. On a quick side note, you can see here how exothermic this reaction was, with it jumping to over 20 degrees Celsius within 30 seconds. While the reaction goes, let me explain the mechanism behind this somehow not illegal reaction. The bleach deprotonates the acetone, which creates an enolate carbanion. The enolate attacks the chlorine in the hypochlorite bleach, which replaces a hydrogen on the methyl group with a chlorine atom. This same process repeats 2 more times until all of the hydrogens on the atom have been replaced, which creates trichloroacetone. The carbonyl carbon is then attacked by an OH hydroxide ion, which breaks the bond between that carbon and the chlorinated carbon. The newly separated chlorinated carbon gets protonated to become chloroform, while the carbonyl carbon becomes sodium acetate. Once the solution had mostly cleared up, I let it run for a few minutes longer before turning off the stirring. If you haven't figured it out already, I'm not very smart. When I tried to separate the chloroform, I poured my stir bar in the funnel with the chloroform and all this stuff, so I had to dump it back out and pour it back in. Chloroform's a lot more dense than the remaining solution, so before I pour it in the 1 liter funnel, you can actually see it at the bottom of the beaker. Because of this extreme density, the chloroform that settles at the bottom of the separatory funnel is relatively pure, and for what I plan on using it, I won't need to purify it any further. I drained the chloroform out into a beaker, and it honestly just looks like water when it was by itself. The idea of smelling it absolutely crossed my mind, but I didn't want to end up on an in memorial post on Instagram. Overall, I ended up with about 12 milliliters of chloroform, which is around a 47% yield, which wasn't great. I kinda wish I'd done a little better, but I can't complain. The chloroform wasn't dried because water helps stop the formation of phosgene gas, and I thought I was going to be doing a second part of this reaction a lot sooner, but that still hasn't happened yet. To keep the product from being exposed to light, which also promotes the formation of the phosgene, I put it in an amber vial, covered with tinfoil, and put it in the fridge. I really appreciate all of you for bearing with me while I was so busy with school, and I plan on releasing more videos sooner than later. I may also release a vlog about my research and my trip to Atlanta to present my research at an ACS conference. I also might release a tier list video sometime soon, because that's something you guys seem to be interested in. And again, thank you for watching, and I hope you enjoyed the video.